In this video, we're going to talk about basic assignments and some of the fundamental data types that you'll find in the language Java. In this video, we're going to make some basic assignments. This is probably going to be the last Java video that I show you everything from start on how to build a project. The next ones I will have it built and opened for us to a blank project just to save time in the videos, because you should be able to get this down with very little practice. So again, I'm going to say File, New, Java Project, and we're going to call this project Basic Assignments. And I'm going to put a V on there because my prior test version is still there. I'm not going to create that extra module. I'm going to come down, open source, add my package name. Then I'm going to add a class, which I'm going to call main. And there it is. So now we have my main class. And what did I forget to do? I forgot to add the method that I need for my main entry. And this is a very, very common thing to do, is to blow right into your code and forget to add that main method. So let's go ahead and add it manually inside the main class, because this is a class definition, so I need to have an entry point for my code to execute. So a method that I can run without having to instantiate the class needs to be defined as a static method. So it's got to be publicly accessible, it's got to be static, and it's not going to return anything, and it's going to be called main, lowercase, and we have a string array called args, and that's it. So there we've now created our main method, because we forgot to check that box when we created this project. Okay, so it is certainly not the end of the world. It's just a matter of filling it in and having that main entry point in your main class. Remember, classes begin with capital letters, methods and variables start with lowercase and are camel case notated. All right, so in main, let's start out with int x equals 4. Now we are no longer in the language Python where the compiler is going to infer our data types for us. We're back to a kind of a C-based type language where we've got to define our data types. All right, so int x equals 4. We can see our first warning, variable x is not used. Well, we know we're going to use it, so we'll just blow right past that. Now let's actually just print x. So system out dot println. You're going to hear a lot of people refer to this as SOP for system out println. A little bit of a slang, and we're just going to put x in there. Let's control save and run it, and we get 4. Thrilling, isn't it? All right, but then let's do an actual sentence, and I will show you with control copy, control V, that we can actually concatenate very easily in this language. The value of x is colon, quote, I can just say plus x. And it's going to automatically give me the two-string version of x. It's going to convert it to a string, append it to this, and send it to the output. If I run it, you'll see what I mean. Value of x is 4. So Java does a lot of work for us, and it's really kind of cool. Okay, any kind of an object or a primitive using its wrapper class has a method that's built in called toString, which will convert its value to string. And Java does what's known as boxing and unboxing, and we'll talk about that throughout this series. All right. I want to show you some things that I'm just going to put in the comments that will be very helpful. One of the things that's interesting is that Java supports printf, just like you had in C. It's a little bit different. And I'm just going to show it to you. It's not part of even the AP College Board's syllabus, but it's worth seeing because it'll kind of tie C into Java. You'll kind of see some of the similarities. So Java does have a utility print formatter. And the way that works is percent, then any flags, then the width, then the dot precision, and then the conversion character. And this is going to look really familiar. So S is a string, D is a decimal integer, F is a floating point, and T is a date, time, value of some sort. But we're going to keep it really simple. We're going to say double Y equals 3.1415926. Okay? Just going to give it that value. Now, I want to show you something. If I were to make this float, it should generate an error, which it does, and it says, type mismatch cannot convert double to float. The compiler already knows that this is too many decimal places for a float. So it needs to be a double. Okay? Because I can't assign that level of precision to a float. So it's now double. Now the only thing I get is that Y is not used. Notice I can hover over the caution here or the yellow underlining here, and it even gives me ideas of how I can fix it. Pretty cool. Now let's just print that. I'm going to steal a system out print line. Get really good at copy and paste in these languages. And obviously we don't want to print out X, so we're going to print out Y. But what I'm going to do here is instead of using print line, I'm going to say print F. And in front of the Y, I'm going to give it the formatting string, which is going to be %2.3 floating, and then it's going to be %n. Now the %n and then quotes, comma. So basically I have to give it the formatting string and then the variable. Now what I've said here is 2 characters wide, so it's obviously less than 2 characters, or 2 decimal places I should say, before the decimal point, and give me 3 afterwards. So I should see 1, 4, and it's probably going to round this, so I should see 2. Okay, so I should see 3.142 if I did this right. So let's save it and run it. And sure enough, 3.142. Okay, so that's just an example of how to do that. Now notice, let's put a comment here. Notice I used %n to do the carriage return. Okay, let's try this with /n. And it still works. We'll really be able to tell here in a minute, because I'm going to print something else out. Let's say system out print f, and we're going to say the value of pi is, we're going to say %2.3 float, and I'm going to say %n, quote, comma, y, semicolon. Control save. Let's run that. Okay, and it's again 3.142. It's kind of hard to see where the cursor goes, but you'll notice that this %y gave me the carriage return. Let's try this now with /n. Notice I get the same thing. So the %n or the /n are determined to be the exact same, give me a carriage return. Okay? And if I say after this, let's just do carriage is here. Okay. Notice I've got the extra lines that I asked for right here. This one gets me the first one, then 2 more lines. Sure enough, I've got 2 lines there. Okay? So that's how you can do that. It works really well. It's pretty simple stuff. And that is basically printf. Again, because in Java we can do this kind of concatenation, you're going to use more of the 2.3 float, 5D structure occasionally to get it the way you want it, but printline is going to get a lot of it for you. Okay, so printf is a very good way to do some printing, to structure it. All right, now we're going to start talking about some of the data types. First one we're going to talk about is a byte. A byte is a built-in, and this should be no shock. It is 1 byte long. So let's create a byte. Okay, so I'm going to say byte, 1 byte, there's a variable name for you, equals, and I have to cast this to a byte in order for the system to not think I'm trying to give it an integer. All right, so the way we cast is we put the variable type in parentheses in front of what we're doing to get it to do the cast. And if I say 255, okay, it looks normal. Okay, let's see if it works. Well, it didn't complain there. Let's see. Let's try to print it out, because that's weird. It took it, but it's only got 1 byte, but it's a signed integer that I put into it. Let me explain. I'll show it to you. If I say system out dot println, okay, 1 byte, I should see 255, right? That's what we think we're going to see. And it looks fine. The compiler likes it. Oh, wait a minute. Oh, it's not used. That's just a not used one. All right, let's go ahead and run this and see what we get. We should see 255. Uh-oh. We see a -1. Okay, now it's suppressed up here, so let's get rid of this with a /n. -1, but we put in 255. This is interesting. So here's what we've learned about a byte. In a byte, the system uses one of the powers of 2 to store the sign. So that means we can only use from minus 128 to 127 because 0 gets a vote. 0 is one of the available values. Okay? So if I change this now to 127, Control save, to run this, now I get 127. Okay? If I go one more, 128, I get minus 128. Weird, right? Because I can only validly store up to 127 in a byte because I'm using one of those values, one of those bits is being used to store the sign. Okay? Important to know when you're dealing with limited numbers of bits, what happens. Okay? All right. Now, we can do a short. Okay? We'll do a short. And a short is nothing more than 2 bytes. Okay? These are pretty simple. So let's make a short. My short equals. Now, I want to figure out what's the biggest, I want to print out the biggest value that I can hold in a short. And I don't want to think about it. I want to look it up. Right? I want to have the system tell me what's the biggest value. Well, there is a wrapper class for every built-in class that comes with some really cool constants that help us out. Okay? Now, a wrapper class is an actual class that wraps the basic data type up for us and extends what we can do with it. It gives us cool methods. So there's a wrapper class for a short. And the way you tell the wrapper class is the data type is the capital letter version because it's a class of that. So if I say my short, I want to assign something in here, I'm going to say go to short and give me, and I hit the dot, and right up here are 2 constants, max value and min value. So I'm going to say assign the maximum value that I can safely put into my short. Okay? And then let's just print it out. So let's say system out print line, Control C, Control V, my short. And let's run that. And there we see 32,767. Okay? Well, let's copy this. Control C, Control V. Now, I'm pretty sure that min value is this with min. But let's say I'm not, I want to make sure. I'll come back here and use the IntelliSense. There it is, min value. Okay? And I don't need to redeclare my short. This is another common mistake when you use a lot of cut and paste. I just need to reassign it. Okay? So now it should print the biggest and the smallest value for short. And there it is. Now notice I can always go one lower than I can go higher. And that's because the positive range includes 0. All right? So that is basically a short. All right? Now, we're going to keep going, and we're going to look at integer. An integer gets 4 bytes. So we're going to say int z equals, here we go again, integer. We're going to use the capital letter of the wrapper class, dot, and I can go max value. And this is an example of auto boxing. Okay, it automatically takes this value and can put it in there. It's unboxing this value into there. Actually, there's better ways I can show that. So integer z is going to get the max value of an integer stored in it. So system.out.println z. And let's do that with min value. And here I'm just going to make this min value. And let's see what we get when we go with error in project. What? Oh, look at that. I did it again. So I'm going to say don't proceed with the launch. And I'm going to go over here and find out. Oh, yep, look at that. I forgot to not reinitialize the same variable. Okay? So now we've got that fixed. Let's run it again. And there we have it. A much bigger integer that we can store. Again, I can go one lower than the top one. So there we are at the 7. All right, so that is integer. Now, the next one we're going to deal with is a long. Because remember, we always want to be cognizant of the fact that we might need more bytes to store things. So long is the class for a really big integer. That's 8 bytes. All right, so we're going to say long I equals long dot max value. And we're going to print that out. Control C. And I'm going to need 2 print statements, so I'm going to do that. Bring it down, make this I. Make this I. Then I'm just going to be reassigning this, Control C, to min value. And you can see how you get faster and faster at this process in your code. And now we've got a significantly larger number. Again, one lower on the negative side, then I can go on the positive side. Okay? So that is long. All of these are integers. All right? Now, just a couple more. Let's show a floating type. There's 2 floating types we're going to go over. First one is float. All right, and a float, let me put that in there, is 4 bytes. All right, and here's what I'm going to do. I'm going to take this and put it here. And I'm going to change this to float. Change this to capital float. Change this to capital float. Change this letter to, let's use F, right, for float. So we're going to print F, reassign F, print F. And now, very quickly, we've looked at a float. And notice I'm getting the scientific notation of what a float can hold. All right? So let's look at how we can store a more precise number is a better way to say it, if we need, which would be a double. So let's put our comment in here. Double is floating point of 8 bytes. Okay? So we're going to use double R, so let's just do this again. Control C. All right, so now we're looking at double, which is 8 bytes. So we're going to change this to double. This is going to be capital double. This is going to be letter R. This is going to become double. Right in the middle of the word float. So let's get rid of that. All right, our spelling looks right. Let's run that. And you can see an even bigger number. Okay, 4.9 e to the minus 324. Okay, now you really want to look up the precisions of these because you're going to start to see errors come in beyond like 15 decimal points and things like that. So doubles, in fact, let me put that out there. Doubles can be trusted to 15 decimal places. Floats, however, are trusted to 6 or 7 places, which means in my mind, I'm only trusting them to 6, just to be safe. Okay, so we've seen the floating points that we're going to talk about today. The other ones are pretty simple. I want to show you a Boolean, which is true or false. Okay, so we're going to say Boolean, we'll call it bool equals, and there's a wrapper class for Boolean. Boolean dot true. Okay, so there's a constant for true, and there's a constant for false in Boolean. So let's print that out. So there's bool. And I'm sure we're going to print it again, so let's do this. Okay, so now we've got Boolean, so we're going to say bool equals false, and we're just going to say it that way because we're not going to use the Boolean false. We're just going to set it to the value false, and you're going to see that they both work. True and false. Okay, so we can use the wrapper class, which will basically unbox that value and put it into the primitive, or we can just use true and false, the lowercase version values, and it works fine. I can go back and forth and do whichever I like. So that is a look at basic data types and fundamental assignments. And we've done all this with some pretty straightforward sequencing. So hopefully this gives you an idea of some of the primary data types that we are going to use. So now you've had a good look at some of the basic data types in Java and some very rudimentary sequencing. In the next video, we're going to take a very quick look at boxing and unboxing between primitive data types and their wrapper classes, whose name is basically whatever the data type is. So int would become integer with a capital I. And we're going to show you how Java will box and unbox automatically when we move values from primitive types into those wrapper classes and back out. It's kind of a cool thing that Java does for us, and we'll take a look at that on the other side.